Section 2.3, direct variation. To solve problems using direct and inverse variation to match the graph of a given function to its table or equation. What is direct variation? It is a linear function defined by an equation of the form of y equals kx, where k is not allowed to equal 0. You can solve the equation for k, and in doing so, I'll have y equal kx, divide by x on both sides, and you'll see that k is going to equal y over x. Very similar to the idea of slope. The constant of variation is the value of k in the direct variation of y equals x. And I've already solved for that here, which is the value of y over x. Procedure to determine if y varies directly with x and how to find the constant of variation and equation. If given a table, divide each y value by the x value and simplify. If the y's over x's are all equal, then y varies directly with x. Number 3, k equals that fraction. That is the constant of variation. 4, substitute the value of k into the equation y equals kx for the equation. In other words, it will become the slope. In our first example, they want us to determine for each function whether y varies directly with x. If so, find the constant of variation and write that equation. So on step 1, we want to place the corresponding y's over their x's and determine if they are equal. So if we have a -6 over a -4, testing whether it's equal, 18 over 12, and again testing whether it is equal to a -21 over a -14. Then I just simplify each fraction to see if this is true. Dividing here, the top and bottom, by 2 is going to give me a positive 3 over 2. Dividing here, the top and bottom, by 6 is going to give me a positive 3 over 2. And again, dividing here, the top and bottom, by 7 is going to give me 3 over 2. Since my fractions are all equal, then it does give me the conclusion that y does vary directly with x. Y varies directly with x. What is the constant of variation? Well, from the procedures on the last slide, it tells me that k is equal to that fraction that we simplified from our y over x's. So here, since they're all 3 over 2, my constant of variation is 3 over 2. Now, I want to find the equation, and I substitute k into y equals kx, which gives me my equation to equal y equals 3 over 2x. And I found all these answers. Y does vary directly with x. The constant of variation is 3 over 2. And the equation is y equals 3 over 2x. Step 2, we want to start with the same procedure on the previous slide, which is to test our y over x's to see if they are equal. So let's put our corresponding y's over x's. That's going to give me a -5 over 1. Test if it equals a -8 over a -2. And if that is equal to 24 over 3. Simplifying, I get a -5, a +4, and 8. These are not equal values. Therefore, y does not vary directly with x. Our next example, set up the same situation, have our y's over the corresponding x's, 6 over 12, -4 over a -2, a -24 over a -6, and now we want to test if they are equal. That's going to give me 1/2 equals 2 equals 4. And in this occasion, this is not true, and y does not vary directly with x. Our next example, testing our y over our x values, 4 over a negative 20 equals a negative 1 over 5, testing if it equals 2 over a negative 10. And when I simplify, this is going to give me a negative 1/5, a negative 1/5, and a negative 1/5. This is a true situation, so therefore y does vary directly with x, and I know that k is equal to that fraction, which is a negative 1/5, and my equation y equals kx is equal to y, substituting for k, a negative 1/5 x. So here we solved all of our questions on our problem. Does y vary directly with x? Since the fractions are equal, the answer is yes. Our constant is that fraction, and when I substitute, that is my equation. Our next examples, they want us to determine whether y varies directly with x if we're given an equation, and if so, we want to find the constant of variation. So recall, we need to write our equations in the form of y equals kx. If we can do that, then it does vary directly with x, and k would be my constant. I also would want to make sure that my coefficient on my y is 1. So here, it is automatically written in that form as, here's my coefficient of 1y, and I have k being a negative 4x, so this does vary directly. So this is y varying with x. And my constant of variation is the coefficient of x, which is a negative 4. Number 2, if I can solve and put it into this form, then it does vary directly with x. Let's divide both sides by 3. Y equals a negative 5/3 x. That is in the form of y equals kx. So here y does vary directly. And my constant of variation is the coefficient of my x, which is a negative 5/3. Number 3, if I solve both sides by dividing by a negative 2, that'll solve for y. Remember, negative 2's got to go into both elements, no matter if they go in evenly or not. Y equals a 6 divided by negative 2 is a negative 3x. And this is going to be a positive divided by a negative 3 over 2. This is not written in the form of y equals kx. That looks like this part of the section is valid, but it has another constant to it, which is not part of direct variation. So here, this does not work. And I'm just going to write does not for y does not vary directly with x. Here, I'm going to solve for y. I'm going to add 2x to both sides. That's going to give me 4y equal to 2x plus 3. I'm going to divide by 4. Y is going to equal 2 divided by 4 is 1/2 x plus 3 divided by 4 is 3/4. Again, this looks like it's going to fit our variation formula, but it doesn't because I have a constant added to it. So therefore, this does not work. And I know that y does not vary directly with x in this problem. Our next problem, I'm going to subtract 4x on both sides. That's going to give me 3y equal to 0 minus 4x is just a negative 4x. When I divide by 3, that's going to give me y equal to a negative 4/3 x. That is in the form of y equal kx, and that tells me that this does vary directly, and that means that k here is equal to a negative 4/3. For our next example, they want us to determine for each direct variation, find the constant of variation, then find the value of y when x equals a negative 3. From previous slides, we know that y equals kx, and therefore, if we solve for k, that gives us k equal to y over x. Therefore, we can just substitute in these two values. Y is 4, x is 9. Then, all we have to do is rewrite the equation y equals kx. And we do know what k is. K is 4/9. Then we just substitute in our other known value, which is x equals a negative 3. So that gives us y equal to, x here is a negative 3. Then we just simplify. 4 times a negative 3 is a negative 12 over 9. And that simplifies into a negative 4/3 for y. For number 2, we can do this a little quicker because we already know that k equals y over x, so k is going to equal y, which is a negative 7, over x, which is 7. Here I can simplify the fraction just to be a negative 1. Substituting into our formula, y equals kx. K is a negative 1. The value of x is a negative 3. And when I simplify, y equals a positive 3. It wouldn't matter if they gave us a y or x. All I would do is substitute in and solve for the unknown variable. Another example, here we can determine k by knowing y over x, which is a negative 2 over 5. Substituting into our direct variation formula, y equals kx. We know k is equal to a negative 2/5. And x from the previous slide is a negative 3. We can find y by simplifying. That gives me 2 times 3, both negative, is going to give me 6 over 5. Again, we can determine k for example 4 to be y over x, which is 4 over a negative 5. Substituting into our formula, we have y equal to, k is a negative 4/5. Again, we do know x. If we knew y, we'd substitute for y and solve for x, but we know x to be a negative 3. Therefore, when I simplify, y is equal to a positive 12/5. For our next example, they want me to determine for each, when y varies directly with x, we want to know if y is 3 and x is a negative 2, we want to find x when y is 8. Here, what we want to do for both of these examples is to set a proportion where I have y sub 1 over x sub 1 equal to y sub 2 over x sub 2. Now all we want to do is label which is which. These two variables come first in our example. Therefore, this is y sub 1 and x sub 1. Our next set would of course be x sub 2 and y sub 2. Now we just substitute in accordingly. Y sub 1 is 3 over x sub 1 is a negative 2 equals y sub 2 is 8 over x sub 2, which is just x. Then we'll simplify by cross multiplication. That gives me 3x equal to a negative 16. Solving the problem by dividing by 3 on both sides gives me x equal to a negative 16/3. Below, we want to do the same thing. If we have y equal to a negative 6 when x is a negative 12, we want to find y when x is a negative 10. So here, I'm going to let this be y sub 1, x sub 1, y sub 2, x sub 2. Use our proportion again. That's going to give me a negative 6 over x sub 1, which is a negative 12. That will give me y sub 2, I don't know, so that's just y over x sub 2 is a negative 10. Simplifying, that gives me a negative 6, when I cross multiply here, times a negative 10 is 60, equal to a negative 12 times y, a negative 12y. Divide both sides by a negative 12. and y will equal a -5. Our next example wants us to write an equation for a direct variation with a graph that passes through each point. Here we already know an ordered pair has a value of x and a y. We know that k equals y over x, which would give us a -4 over 3. Also, we know that the direct variation formula is y equals kx, and all we need to do is substitute in and get y equal to a -4/3 x. Now we can continue pretty rapidly by knowing that this ordered pair is an x and a y, and we know that y equals kx, and we know y equals k is going to be a -6 over a -5, which is 6/5 x. Our last one, x is 5, -3 is y. We know y equals kx. We know y equals k is going to be a -3 over 5 x. And here are the three equations for each of my examples. Our last two examples, they want us to determine whether a line with the given slope through the given point represents a direct variation. In other words, can I write an equation with the given slope and determine whether this point passes through that equation? Well, we know that this is y over x, so this is actually our k. So I can just write y equals kx to be y equals a -1/2 x. Then all I need to do is substitute my x and y value into this equation and check to see if it turns out to be true. If it's true, then it is a direct variation. If it's not true, then it's not a direct variation. So let's substitute in. For y, I'm going to use a -4. My k is a -1/2. For x, I'm going to use 8. And that will give me a -4. -1 times 8 is a -8 divided by 2, a -4. And we want to determine if this is true. This is true. So that means this is a direct variation. So the answer is yes, it is a direct variation. Our next example is m equals 5 and our ordered pair is 2, 15. Again, we want to create an equation. We know that this is k, it's 5 over 1, so y equals 5 over 1 or just 5x. And this is our equation for a line, and we want to determine if this point will fall on that line. All we have to do is substitute our x and y value and determine if our equal sign is true. Y is 15. 5. X is going to equal 2. Therefore, 15 and 10. And we check for equality, and it's not equal. Therefore, this point does not fall on the line generated by this equation. Therefore, this is not a direct variation.